Okay, so today we are looking at domain and range. So if we take a look at the first page of this note sheet, domain is all your x values. We've been talking about that. All the values of x on the x-axis that the graph takes on or covers. So to find the domain of a graph, if you're given a graph, you're going to start from left to right and move along the graph and note which values of x are covered and which are not. All covered values of x are in the domain. So let's take a look down here at this example. You do want to kind of pay attention to the ending. See how this end has an arrow on it? I'm going to make it a little bit bigger just so you can see it a little bit better. So that means that this is just going to keep going forever. On this side, we don't have an arrow. This whole graph is starting right here. So that's a firm endpoint. So in other words, this graph does not exist back here. Okay? Another thing that we can assume is that this just keeps going in this direction. Like it's not going to, once it gets off the graph, it's not going to do something crazy and swirl around. Okay? So it just goes off. It's like, you know how something in space, if you send something off in space, it just goes forever, right? And it doesn't even change its course unless it hits something else. So weird to think about, right? Gosh, where does it go? I don't know. But anyway, same idea. So this has a firm starting point, and then this one just goes off. But it's not going to do anything crazy. It's not just all of a sudden going to zig back the other way. Just goes, okay? So if I want to look at the domain, right? So I go left to right. Nothing's happening here. Nothing's happening here. Here's the first x value that I actually have. And then won't all of the x values in this direction eventually be covered by this graph? So in other words, when I want to evaluate this function when x is 2, there will be an answer, won't there? Yeah, at 2, it looks like my y value spits out something a little bit less than -1. When x is 5, there will be an answer, right? 1, 2, 3, 4, 5. So it's not quite there yet, but remember, this is going forever, so eventually there will be a value when x is 5. Will there be a value when x is 100? Yeah, because this is just going to go on forever. So eventually all of these x values will get covered. What won't get covered is anything this way, right? Because the graph is never coming back over there. So in order to say the domain, we're going to have a definite starting point right here, and then it's just any x values that are greater than that. Okay, so we're at -4 here. So the domain it starts at -4, so I do want to include -4 as part of my domain, and then everything greater than it. Okay, so if we look here, exactly as you see it. My domain is all the x values greater than or equal to -4. And then for the range, we do the same thing just on the y-axis. Right? So you're going to start at the bottom and move to the top and see which y values are covered and which are not. So if I look at the bottom of my graph, I don't have any y values down here. Will I ever get a y value down here? No, because this thing, it started here and it's going to keep going this way, up and over forever. It's never coming back down. This is all I've got. Okay, so I don't have any y values down here, and then I think this one's supposed to hit perfectly at -1. It looks like it dips a little bit below, but assume that it's hitting at -1. That's the first y value I get as I go from the bottom up, right, is -1. And then I do get y values, everything above that. Does that make sense? So I'll never get a y value down here, but I'll get y values all the way up for forever in that direction. Yeah? So if I look at the range, it's going to start at -1, and I want to include it, so greater than or equal to -1. I start here, and I just go up. Does that make sense, kind of? Okay. So let's go ahead and try and not look at the answers on the next page. Don't look at the domain and range. Cover it up real quick. Yeah, right there. So don't look at what the domain and range is. Just look at the graph. Okay, so another thing that we need to talk about here. This particular graph doesn't show arrows on the ends. They are intended, okay? So if it goes all the way to the edge of the paper, you can assume that it just keeps going. So even if there are not arrows there, if it's going to the edge, you can assume that it continues on, which is a little bit different from the one below it. Okay, this does not go all the way to the edge of my grid. This is a hard starting point. This is going to keep going. Right? So if it goes all the way to the edge of the grid, you are allowed to assume it's going. Many times they'll have arrows on them, but if they don't, that's okay. All right, but you would never add an arrow on the interior of a graph. Right? If it's not clear that it's continuing on. All right, so let's go back up to this one. So let's talk domain. Think about what's going on here. This is going to keep going up and out forever on both sides. Keeps going up and out forever and ever and ever. So if I ask you what the value of this function is when x is 1, is there an answer? Is there an answer when x is 2? 5. When x is 5, will there be a y value? Yeah, I just can't see it on my graph, right? Because here x is 5 right about here, and it would just be something way off my graph. But since this is continuing on, there will be an answer. I just can't see it. Will there be an answer when x is 100? Yeah. It's just way off my grid. What about when x is -10? Well, let's backtrack. How about -1? Is there an answer when x is -1? -2? -3? -4? Yeah. So it's going to continue on forever in this direction too. So are there any x values that are not covered by this graph? So, what'd you say? Oh, right, yes. All x values are covered. So that means that my domain will be all reals. And are you familiar with this notation? The little funny E looking thing? So it basically means is an element of. So that's saying that x is any number in the real number system. That's basically how you could interpret that, okay? So that symbol right there means is an element of.
Do we have to put that?
No, but it's a good habit to get into. How about the range? Think about the y values for this graph. Is there a value of x that would spit out a y value of 2? Yeah, so here's y is 2 right here. Looks like I actually get 2 answers. So yes, I will get a y value of 2. Will I get a y value of 6? Will I get a y value of 10? 20? 100? -1? No. Look, there is no, remember, these are going to keep going up forever. They're never coming back down. So I never get a y value that's down here. So all of this cannot be included in my range, right? So it starts here. I take the lowest point that I have. Ding, 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 there it is. So I'm going to get this and everything above it. That means my range has to be greater than or equal to 0. Correct. Because that's the smallest value I ever get in the y direction, and then I get everything above it. Okay? So, y should be greater than or equal to 0. Hopefully you didn't look at the domain and range for this one. So go ahead and try it yourself. See if you can Decide what you think that domain and range would be. Remember that this time I have a hard stop right here, and this side's going to continue on forever. So I kind of want to think, all right, will I get every x value in the whole wide world? Is every x value covered? Is every y value covered? I don't know. Who thinks I have the domain? Evelyn? Yes, you're right. You're doing that notation we're going to talk about in a minute. Yes. I am starting, my domain starts at 0 and continues on forever in this direction. So, you could write it as x is greater than or equal to 0. We are going to learn the bracket notation in just a minute. If you already know it, great. If you don't, that's fine. And how about the range? Who's got the range for me of this one? Range. Yes, you are correct. The y's are also greater than or equal to 0. We're okay? Is this old news? All right, good. Well, what do you know? Check this out. Interval notation. Can you do me a favor and raise your hand if you already know this? Okay, so there are some of you that don't. All right, that's fine. So, interval notation is another way to write inequalities. So let's take a look. Here, x could be greater than 5, but you're not including 5, right? So if you want to write it in this new notation, it's not an ordered pair, okay? I know we're using parentheses, but it doesn't mean that. So this is I like to think of these as like a soft stop, and these are more like a hard stop. So if I have the or equal to part, it's a hard stop. If I don't, it's a soft stop. That's how I think of it anyway. So this is saying, yeah, you can have anything that's bigger than 5, and then it's also going to go to positive infinity. So in other words, I start at 5, and then I can have everything bigger than 5 up to infinity. Does that make sense? And you're always going to have a soft stop on infinity, because there's no end to it, right? Yeah. So now if I want to include that 5, so if I want x is greater than or equal to 5, I'm going to start at 5, and then again I'm going off to positive infinity, but I use this straight bracket here to include the 5 if I want to. Okay? So if I have the or equal to, I'm going to make it straight. If I don't, I make it smooth. Okay? Now, let's take a look at this one. Now I want x is less than or equal to negative 3. So, my graph is coming from, I want all the numbers that are less than or equal to negative 3, right? So if I were coming in from the left-hand side, I'd be coming from negative infinity, right? So maybe that makes more sense. Like whatever number goes first, that's where as you're moving from the graph left to right, where are you coming from? So on this one, if x is going to be greater than or equal to 5, think about what that graph might look like. If you had the range, the domain that was, say it was something like this, right? So that's 5. There's 0, right? So if I'm trying to give this domain using this notation, coming in from the left, the first thing that I hit is a 5. So that number comes first. And then I go off to positive infinity. If I'm looking at this one, right, and I had the same thing, but the domain was something like this. Well, this is less than, oh yeah, so these should be open dots actually. Make that an open dot, because it has the less than. So, same thing here. That graph might look like this. As I'm coming from the left, I'm already in my graph. The graph already exists coming from this way. So that's why I'm starting at negative infinity, and then where does my graph stop? It stops at negative 3. Does that kind of make sense? Okay. And then I do the same thing. If I had the or equal to bar underneath, I use the hard stop. the straight bracket. So do me a favor, somewhere on your paper, use interval notation to try and do this one. What would x is less than negative 1/2? What would that look like in interval notation? Think about where is my graph coming from, and then where does it stop? If it helps you to draw a sketch of a graph that might have this domain, right? That might look something like this. So where's it coming from? What would my first number be? Yes! The square one or the round one? Round! It's coming from negative infinity. And where does it stop, Evelyn? Negative 1/2. And do I use this? Yes, I don't have the bar underneath, so I don't do the square one. Square is only for the bar underneath. All right. Okay, now let's make it a little bit more complicated. Now we have a compound inequality, right? So this would represent a domain that's starting really at negative, well, anything bigger than -2, but it's going to stop at 4. Okay, so could you imagine that? So this graph might look something like this. I don't know. Goes from -2 to 4. Maybe something like that. So I have two definite endpoints, right? So my domain coming in from the left, the first thing I hit is that -2. I don't want to include it, so I have to have a soft end here. Then I keep going, and then my graph ends at 4, so I have a hard one there. Okay, between 5 and 7. That makes sense. Yep, same thing. I'm going to use the hard stop here because I have the or equal to bar. Soft stop here because it's only a 7. And then between 1 and 6, they're both hard stops because I'm including both of them. So I use the square bracket on each side. Does all this make sense so far? Everybody's okay? I'm wondering... Okay, we need to do one like this. What happens if I had... what if I had x is less than 2 or x is greater than 5? What if that was my domain? How would I write that in interval notation? So let me draw you a sketch of a graph that might look like this. My graphs are not that creative. Say it was that. And this is 2 and this is 5. Is every x value in the whole wide world covered? No. Right? I don't have this one in the middle here. So basically what we do for things like this is we use what's called a union. Okay? So I'm going to give the interval notation for this part, and then I'm going to union or join it with the interval for this part. And then that should give me the domain for the whole graph. Okay? So, how about this part, the x is less than 2? How would I write that in interval notation? Yeah, I have to, if I come from the left, I'm already in the graph, right? So I'm coming from negative infinity, and I'm stopping at 2 with a soft ending, right? So now to join it with this one, we literally, it's just a capital U, like a union, and then I do it the same thing for this side. So this side, coming from the left, right, if I'm just looking at this part, it starts at 5. So a soft parenthesis, and then it goes to positive infinity. And there you have it. So that would be how to represent a domain like that. So you might see those unions here and there. Does all this make sense? Okay, so try and cover up the answer to the bottom. I should have made it with them blank. I'll try and do that next time. Okay, so if we're looking at this graph, let's start by writing the domain in the old notation, and then we'll try and see if we can convert it to the new. Okay? So let's look at our domain here. Notice I don't have arrows on anybody. They all have definite starts and stops. So coming from the left, where's the first number that I have an answer for? -4. Okay, so I know that I need a domain that goes from -4, and I include -4, but then it stops here at -2. So the domain for just this piece, wouldn't that be in between -4 and -2? So wouldn't it look like that for just that part? Okay, then what would the domain, go ahead and write what you think the domain for this piece would look like. You got it? You tell me if you match what I have. Yeah? So that one is in between 0 and +2. And I want to include both of them, so I have the bars underneath. And then this last piece would be that's 5, right? Just like that, wouldn't it? I'm not, that one has an open circle, so I don't want to include the 5. All right, now take a minute and see if you could write this in the new notation. Since I have these 3 kind of separate pieces, I am going to have to use that union. Okay, so this one, do I do the square bracket or the round bracket? Square to start off, so I'd have square -4, comma, -2, and then I round. Yes, and I'm going to union that to join that with this one. They both have the bar underneath, so they're both square brackets. So 0, 2, and one more. 3 to 5. Smooth on the end. Oh, sorry. Did you get it? No? What'd you miss? Or do you know now what you did wrong? Okay. Okay, range for these. Let's talk range. We get kind of lucky here, because even though there's 3 separate kind of parts to this graph, don't they all cover... Oh, actually, that's a good point. They all start at -1, don't they? Okay, so -1 is definitely in my range. I'm sorry. Why did I say -1? Blah, 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 blah. I meant +1, right? +1 is in my range. That's the first y value that I'm getting as I go from the bottom to the top. So 1 is in my range. Is 2 in my range? Yes, right? I get a bunch of answers for 2. 3! Yes! Now, these are both open at 3, but that one's closed. So it doesn't matter how many are, as long as someone is closed, that means that 3 is in my range. Because there is an x value that will spit out a 3 as an answer. I don't have to have multiple of them, I just need one. So if anybody gives me a y value of 3, that means 3 is in my range. Does that make sense? Is 4 in my range? No, nobody would spit out a 4, so I'm definitely out there. So I know that I need to start it at positive 1, and I need to get all the way up to 3. Okay? So for my range, in the old notation, we would say that y now has to be greater than or equal to 1 and less than or equal to 3, right? That would be our old notation. I'm going from in between 1 and 3. And I do have values for 1 and 3, so they're closed or with the bar underneath. So now, in the interval notation, square or round? Square. 1, comma, 3, square round. For the end. Square. That's it. So there's my range in interval notation. Yep. I think I usually specify which one I want, and if I don't, then you can do whatever you like. All right. Don't look at the answers. Cover. Don't peek, don't peek, don't peek. All right, so let's talk about what this graph, there's a whole lot going on here, right? So this goes all the way to the end, so that one's just gonna, if you want to add an arrow, if that helps you sort of visualize things, go ahead. And you can add one over here. You could never just come in and add one here. It has a definite stop, so only on the very ends in this case. All right, so let's think about this. So it looks like this graph is coming from negative infinity, and then all of a sudden when I hit negative 1, I don't have an answer here, but I do have one here. Okay, and then I go along, go along, go along. I don't have an answer there, but I have one here, and then I go along, go along, go along. Let me ask you this question. Is this thing a function? Does it pass the vertical line test? So, vertical line test, remember, you want to pass a vertical line, and anywhere, if it has more than one value, anywhere on that vertical line, then it is no longer a function. So the places of interest are like right here. What is the value of this function when x is negative 1? Is it this? No, because it's open. That means there is no answer there. So if you plug in negative 1 into this function, you are going to get an answer out, but it's not this, it's that. So when you plug in negative 1, there's only one number that comes back out at you. And this does pass the vertical line test right here, because it is not, if that were closed, it would fail. But because it's open, that means you don't have an answer here, you've got it here. You can't have two closed dots on top of each other. That would break. You can have 100 open dots on top of each other. That doesn't matter. Because there's no answers there. It's just saying everything up until that point. Okay? So it doesn't fail there. And then I kind of have the same thing happening here. So if it didn't fail here, it's not going to fail here either. So again, because when x is positive 1, you don't get that answer. You get that one. And then you continue on, continue on, continue on. Does that kind of make sense? Okay. All right, so let's talk about the domain. So we have established, yes, this thing actually is a function. It did pass the vertical line test. If I'm going to do domain, right? If I do it in the old notation, well, let's see. Are there any values of x that I won't get? No, I can plug in any number I want for x, and there's an answer that comes out in y. Some of them are weird, but they still come out. Since this is going to keep going on forever, and this is going to keep going on forever, that means domain is everything. So remember how we were going to write that? X with that funny e thing is an element of the real numbers. How would you write that in the new notation? Yes! It's coming from negative infinity and it's going to positive infinity. That's what that would look like in the new interval notation. How about range of this thing? This is going down forever. This is going up forever. Are there any y values that you won't get? No, they are actually all covered. Right? Some more than once, but that's okay. Everybody is at least covered once. So that means that my range is going to be in the all reals too. So y is going to be an element of all reals. And then I would do the same thing. Negative infinity, positive infinity. Does that make sense? Okay. All right, this one at the bottom. Woo! So you try it. Let me give you a minute. Go ahead and write in both types of notation, the old and the new, what the domain and range of this thing is. If it helps you to add the arrows to the ends, I always like to, but you don't have to. So that's going to keep going forever in that direction, same as over here. This will keep going forever in that direction. Okay. Let's start with domain. Are there any x values that you won't get that are not covered by this graph? Oh yeah, I actually didn't. I was like, oh yeah, no, they're all there. 4, right? 4 is not included. There is no value of this function when x is equal to 4. So, I can have everything less than 4, and I can have everything greater than 4, but I can't have 4 itself. So, did you write something like, I can have x is less than 4, or x is greater than 4? Something like that? Okay, so now if I want to put that in my new notation, I'm going to have to use that union, right? Because I have two parts of my domain, over here and over here. So this guy is going to look like what? How do you write this? Negative infinity to 4. Because remember, from the left, I'm coming in. I'm already coming from negative infinity, and I go all the way to 4. And that's kind of where I stop. Then I'm going to hook this back up with everything after 4. So now I'll start at 4 and I'll go to positive infinity. Smooth curves, smooth parentheses, all the way around. So there's my domain. How about the range, though? Will you get every y value out there? No, you don't. So if you kind of look at this, coming up from the bottom, everything's covered because this guy's going to keep going down forever, and so is this one. So all of these y values down here, I'll get them, but then I top out. I'm never going to get a y value. We can assume that that's 6 if you called it 6.1 or something, whatever. But I'm never going to get y values up here. No part of my graph is up here. These ends are not going to swing around and come back up. They're going off to space. Negative infinity. Off they go. So my range in the old notation, if I'm assuming that that's 6, my range would be anything less than or equal to 6. Right? Because that's the highest I'll ever get, but I'll get everything below it. So now in my interval notation, since I am including 6, I do have a value at 6. I'm going to use a hard stop 6. And then where am I going to? Negative infinity. Correct. Smooth. Because it'll just keep going down forever. Oh, shoot. But I did it backwards. Right. You always got to start from the bottom up. Whoops. So from the bottom, I'm coming from negative infinity, and I top out at 6. Woo! My goodness gracious. So then I got to switch my... You're smooth. You're hard. Sorry. Okay. All right. Let's actually skip to... There's 2 more examples, but I'll let you try those on your own in a minute. Skip to the next page where it says finding the domain algebraically. Now, what happens if you don't have a graph in front of you? Sure, you could take the time to make the graph, but sometimes it's just not convenient, and it's many times it's not accurate, right? So we can't always do that. We just don't have the time, we don't have the resources. So, you can find the domain algebraically. How? Well, let's take a look. Most functions will have a domain of all real numbers. That means there are no restrictions to what the x value can be. So here's an example. You can plug in any real number you want for x, and you will get an answer out for y always, right? You can plug in 1.275. You can plug in 1,000,000. It doesn't matter. You can plug in anything you like in the real number system, and you get a real number back out, right? For something like this. Agreed? Agreed. Okay. But sometimes you can't. So let's take a look at the next page. Let's just look at the example quick here. Can x be anything I want in the whole wide world in this example? No, because I'm never, ever, ever allowed to have a 0 in the denominator. So there is an x value that would cause me to have a 0 in the denominator, so it cannot be part of my domain. Does that make sense? Okay, so one way to find if I have a function that has a fraction with a variable in the denominator, right? Because if it's just any old fraction, it doesn't matter. But if I have a variable in the denominator, I need to make sure that whatever number I plug in for that variable does not make that denominator turn into 0. Okay? So when I see a function like this, I'm like, oops, that has a variable in the denominator. I can't ever let it be 0. So all I'm going to do is I'm going to take that denominator, whatever it is, and I'm going to set it equal to 0. And I'm going to solve for it, and I'm going to see what value am I not allowed to have. What value cannot be in my domain. This one's very easy, right? Obviously it's -5, but sometimes maybe you have a quadratic in the denominator. you would have to solve it and see, well, what values am I not allowed to put down there? I can't have them in my domain. Does that make sense? Okay, so, I mean, this one was pretty easy. I know it can't be 5. So the domain of this thing, if you were going to use your interval notation, right? If I can have everything except 5, doesn't that mean that I can come from negative infinity and go all the way to 5, but I can't include 5, and then I want to go from 5 off to positive infinity. Yeah? Okay. So that's one time. If I have a variable in the denominator, have to figure out what would make that denominator be 0, get it out of my domain. All right. The other thing that I can't do is I can't take a square root of a negative number. Not just a square root. Can you take a cube root of a negative number? Yes. Can you take a fourth root of a negative number? No. All of the even index radicals, so a square root, a fourth root, a sixth root, any of the even ones, you can't have a negative under there. Okay? So if you look at the next example, this one's a square root. What's the smallest thing I can take the square root of in the real number system? 0. I can take square root of 0, it's just 0. So I kind of do the same thing. I'm going to take whatever is under my root and set it equal to 0. And that's going to be the smallest thing that I can have in there. I can have that or anything bigger than it. Okay, so let's look at this one. We're going to take 3x minus 4, and whatever is under there has to be greater than or equal to 0. Because it has to be 0 or something positive. I can take square roots of positive numbers all day. They may not be nice, but so what? I can still do it. Right? 2 has a square root in the real number system. It's just not a convenient one. Okay? So, this has to be greater than or equal to 0 under there in order for me to be able to actually take that square root. So, that's exactly what I do. Take whatever is under the radical and set it greater than or equal to 0 and then solve that inequality. So, that is my domain. That's what I'm allowed to plug into this function, and I'll actually get an answer back out. Does that make sense? So if you tried to plug in something that was not in this range, like if you plugged in 1, for example, because 1 is not greater than or equal to 4/3, correct? So 1 should not work. Go back to the original. If you plug in 1, is that going to work out for you? No, because 3 minus 4 is negative 1. Now you're not in the real number system anymore. Does that make sense? So there's my domain. Go ahead and try writing that domain in interval notation. What would that look like? And then off to positive infinity. Good. Okay, so let's try a couple of these. Here, I have a function that is a fraction, and there is a variable in the denominator. So what am I supposed to do here? I'm going to take this guy and set it equal to 0 and solve. Whatever comes out cannot be in my domain. I don't care about the numerator. The numerator can be whatever it wants to be. It doesn't matter. I don't really care about it. It's the denominator that I'm nervous about. So I'm going to take that denominator, x squared minus 4, set it equal to 0, and then I go ahead and solve. So I'm sure you probably already have the answer. Did you get, oops. Positive and negative 2? Okay, so I can have everything in my domain except that. All right, so we're going to write this in interval notation. Let's try it. I can come all the way from negative infinity, and then I can get up to, yeah, let's go to negative 2, right? So I can go from negative infinity to 2, and then I can go from negative 2 to where? Positive 2, And then I can go from positive 2 to infinity. Does that kind of make sense? I can have everything else, but I can't have those two. I can't have negative 2, and I can't have positive 2. So that's how I kind of have to break it up. Let's try one like, oh. I was like, let's do the last one. The one right next to this is the same thing. All right, let's look at this one. This one's not a fraction, so I don't have to worry about a 0 in the denominator. What do I have to worry about? I can't have a negative under there. So whatever this is, 4 minus 2x, has to be greater than or equal to 0. I can take the square root of 0, but I can't take the square root of a negative. So whatever it is, it's got to be greater than or equal to 0. So now I'm just going to quickly solve. Don't forget that when you divide by a negative, what happens? Yeah, you got to flip that symbol over. Remember that? Let me zoom in a little bit. So right here, see how I divided by negative 2? When you divide or multiply by a negative, that inequality symbol flips over.